Hello friends, my name is Dipen Dikshit. I am from YouTube video channel of Dipen618. In this existing video lecture, we are basically going to deal the concept of LVM, or you can say the logical volume manager, through which we will manage the hard disk in different ways. So guys, here I have just prepared a short PPT for you. So here you can see that just after the installation of Linux operating system, automatically at least two partitions are created by default. The first partition is your root partition. It stores all folders and files which is created in Linux. Okay, so this is the first, and the second one is your swap. So it is actually used to act as a virtual memory, and I hope guys that you know what is virtual memory. Again guys, we are going to deal with LVM. So see here, full form of LVM is logical volume manager. It is used to manage hard disk in Linux environment. Managing hard disk means below given points. It can resize means extend or reduce VG and logical volume. It is also help in creating a snapshot of logical volume, and it also helps in creating RAID logical volume like RAID 1, RAID 3, RAID 5. So all this kind of lab means in this lab we are going to create PV, LV, RAID and different type of things guys. So this is about LVM. Now guys, we will study about PV. So the full form of PV is physical volume. It represents the hard disk which can be seen from our naked eyes and is physically attached to the Linux server. Now if you talk about LV, then the full form of LV is logical volume. It represents the different partitions existing on hard disk like root partition, swap and many other kind of partition that we create on hard disk. Now guys, what I have seen that many times or many of us are confused with PV and LV, that what is basically the difference between PV and LV. So I have tried to explain the difference between the PV and LV. One easy way to differentiate between LV and PV is that LV can extend on multiple hard disks, but PV is limited to single hard disk. Now ultimately guys, VG or volume group. So this is made by combining PV and LV. By default one VG exists on Linux, but we can create more than one volume group in Linux. So this was a small theory which is important for you before starting the lab on LVM. So now guys, we will start our lab. Now guys, we are on Red Hat Linux 6.0, and here you can see that we have logged in through root user. Now guys, we will see that what are the default PV, LV and VG created on the Linux operating system, and also we will see that what are the different partition created by default on Red Hat Linux. So guys, for that open this command prompt, that is the terminal, and here guys, first we will see that how many hard disks is attached to your Linux server. So for that you will write here ls means ls /dev /sd star and press enter. So guys, at the present moment we have only one hard disk attached to our Linux server because we have only this SDA. Okay, if there would be two hard disks attached to this Linux server, then here we will see one SDA, and for second hard disk we will see SDB. Okay, so at the present moment you are seeing only SDA, so only single hard disk is existing. Now guys, here you are seeing SDA1. So SDA1 is your boot partition and SDA2 is your PV or physical volume. So guys, this is the explanation of the data that you have seen here. Now guys, we will see that what is the work of this F disk minus L. So guys, here try to explain, try to understand some of the important thing here, which the report is here getting generated, that your SDA, which represent your physical hard disk, the full size of your physical hard disk is 10.7 GB. Okay, here guys, this slash dev dm minus 1, it represent the SDA1, or you can say the boot volume, and this slash dev dm0 represent the PV, which is physical volume, and its size, which is 9 GB. So for boot we have 1073 MB, or you can say 1 GB, and for PV we have 9 GB. And guys, on this PV, your root and swap, the two different partitions we will create. Now guys, one thing more I want to say you, that whenever the hard disk you attach to your Linux server, then those hard disks appear inside Linux operating system in the form of file. Okay, it is not like Windows that you will see there the hard disk icon and you will click it and all the folders will be displayed. Actually, all the hard disks are existing inside this dev name folder in the form of file. Okay, so when you go inside this dev name folder, then guys, here you can see that if you press here S, then here you can see guys, inside this, just wait for a moment. Yes, here you can see this is your hard disk, but it is existing in the form of file. Okay, and here is the PV and here is your boot volume. Okay, and guys, this dev name folder that here you are seeing, it contain all the hardware devices which you attach to your server externally. Like whether it is not only the case with hard disk, it is also with CD-ROM or any external device that you attach with your Linux server. All of these external devices appear in the form of file inside this dev name folder. Actually, inside root drive we have many folders like boot, file, home, but if you want to see the external device that you have attached to the Linux server, then you will focus on this dev name folder. Okay, whose full form is device, and this boot folder, which represent your that SDA1, it contains all the files which is responsible for booting the Linux operating system. So this is basically how all the thing goes on inside this. Now guys, we have the idea of this. Now we will see that what are the default PV existing on Linux, what are default LV, and what are default VG. So for that you will write here PV display, and guys, here I have already told you that this 9 GB is the size of your SDA2, which represent PV. So we will make it clear now. So click PV display. Here guys, you are saying that SDA2, which is existing inside this dev name folder, is a PV and its size is 9.51 GB. Now guys, if you want to see the LV, or you can say the logical volume, so for that you will write here LV display, and guys, you can see here there that here is your root partition and here is your swap partition. The size of your root is 8.51 and the size of your swap is 1 GB. So if you add 8.51 plus 1 GB, then you get 9.51 GB, which is the total size of your PV, which is SDA2. Okay. So guys, I want to explain a few things more before proceeding to the next lab. Here guys, we are seeing the SD. So actually when you do lab on Linux server, then you will see two type of hard disks, the SD hard disk and the HD hard disk. Okay, so this SD hard disk means that the hard disk that you have attached to your Linux server is your SATA hard disk. Okay, and if you see here HDA or SDB, then you should be assured that the hard disk that you have attached to your Linux server is the IDE hard disk. Okay, so if you have a little knowledge of hard disk, so you can easily understand that what is SATA hard disk means, which uses the SATA wire for connection, and SDA which uses IDE wire for attaching your hard disk to the server. So this was a small concept that was missing. Now guys, we will see the same information with the help of Graphical Console. Okay, so for viewing the same information with the help of Graphical Console, you have to install one RPM. Okay, so here you will install yum-y install system minus config minus LVM and press enter. So guys, you can see here that system minus config minus LPM RPM has been installed, and guys, now you can manage your hard disk through graphical way, or you can say using graphics process. You will go into system, go to the administration, and here this logical volume management, which is and here guys, logical volume management will appear in front of you, and here you can see guys that configure LPM in a graphical setting, so which is quite easy and fast. So guys, here your logical volume management console has appeared in front of you. You can see here guys that here is one volume group, and the name of the volume group is your VG_Vishnu. Okay, and guys, inside this VG Vishnu we have one physical volume, and you can see the name of the physical volume is this. This is the name of the hard disk, SDA, and this is the name of your physical volume, which is SDA2. Moreover guys, you can see that this volume group also is made up of a logical view, or you can say the logical volume, and there are two logical volume. First is your LV root and second is your LV swap. And inside this guys, we have uninitialized entity, which is SDA, and inside this SDA we have this SDA1, the partition 1. Also guys, if you click on this VZ guys, which is VG_Vishnu, which is a volume group, then here guys, after clicking it, you can see that this volume group consists of LV root, and the space or the storage of this LV root is up to this extent, and this LV_swap is having the storage capacity of only this much extent. Okay, in the same way guys, here you are seeing this SDA2, which is your PV, and we know that your volume group is made up of both PV and LV. In the same way guys, if you focus on the right side here, that what are the properties of this volume group, then here guys you can see the maximum size of this VG, and who are the m- member of this VG. Okay, in the same way guys, if you click here this SDA, and here guys you will click this two partition, then here guys you can see that this PV, which is SDA2, is made up of LV underscore root and LV underscore swap. And if you want to know the size of this PV, then here guys on the right side guys, the property of this PV, here the exact total size of this PV is given. Guys, up to this extent we have all the theoretical ideas related with LVM and its different LV, VG and many other such kind of things. Now guys, we are going to start with our lab, and the first lab is that, suppose guys we already know that root drive, or you can say the root volume, is a volume on which all the folders and files are created in the Linux operating system. So guys, if your storage capacity of root volume has become full, and now guys you want to extend the size of root volume, so how you will do it? So for doing such type of lab, you will attach an additional hard disk to your Linux server, and then guys we will extend the root volume with that external, or you can say the additional hard disk that you have attached to the Red Hat Linux operating system. At the existing moment we have already one hard disk, which is SDA, which is attached to your Linux server. But when we will attach an additional hard disk or the second hard disk, then we will get another hard disk which is SDB. And so now we will see this, that how to attach hard disk to your operating system, or you can say Linux server. So I am shutting down my Red Hat Linux operating system with init0 command and wait for the shutdown of it. Completely shut down the Red Hat Linux operating system. Now guys, for attaching an additional hard disk or for attaching a second hard disk to our Red Hat Linux server in VMware, what you will do, you will simply click this edit virtual machine settings, and then guys here you will choose this hard disk, which is SCSI, and press add. Here you will choose the hard disk option, click next. Here you will choose create a new virtual hard disk, click next. So guys, here you can see that we have two type of hard disk. One is IDE and another is SCSI. SCSI is made up of SATA hard disk. So guys, here also guys recommended is SCSI, so you will choose this SCSI drive and you will click next. Here you will give the size of your hard disk, which is 10 GB. Here I am taking, and here you will click this allocate all disk space now, and then you will click next. So now guys, after clicking finish, the disk is going to be created, or you can say the second hard disk is on creation. So guys, as here you can see that we have created a second hard disk which is of 10 GB, and this is our previous hard disk. So now guys, you will click OK, and then guys I am starting my Linux operating system. So guys, our Red Hat Linux operating system has been started, and we have logged in through our root user. Now guys, we have added the second hard disk to our Linux server. So we will verify that whether that second hard disk is added to our Linux server in a proper manner or not. So for that we will again run that command on terminal, that is ls/dev/st* and press enter. So guys, here you can see that SDB, here you are seeing a second hard disk whose name is SDB, earlier I have also make you aware that your first hard disk is represented by SDA, and if you attach a second hard disk to your Linux server, then here you will see this SDB. Okay, so we are verified. Now guys, what we will do, we will create a new we will create a new partition on SDB, and it will occupy all the space of this SDB. Okay, so if you want to verify that this SDB is having what size, then that you can also verify. So the command for creating all such things is here fdisk /dev/sdb and press enter. Here you will write P and then press enter. So guys, here you can see the size of this SDB, or you can see the second hard disk, is 10.7 GB, and no partition is created on this SDB. So it is just like an empty hard disk. Now guys, we will create two volume or two partition on SDB, and guys, one volume will be having the space of 5 GB, another volume will be having the space of 5 GB. So guys, for creating the two different volume, here you will use the option N and press enter. So for guys, the primary volume, you have to choose the option P and press enter. Give the number 1 because this is the first partition that we are going to create. Then guys, press enter. Then guys, here you will write 1, and then guys, here you will give the size of this first volume. So guys, I want the size of this first volume to be 5 GB. So for GB guys, you write here capital G, and then guys, press enter. So guys, we have created the first volume of storage 5 GB. Now guys, we will again create the second volume, and for that we will write here N, press enter. Then it would be of the primary type. So for that, press P and again press enter. Then here guys, you will write the option of 2 because this is the second volume that we are going to create on SDB, and press enter. Then again guys, give here guys, don't give any size because only 5 GB is remaining on SDB. So we want that all the remaining space on SDB will be utilized by the second volume. So for that, don't write here anything, just press enter, and then again just press enter. So guys, all the remaining space on SDB will be occupied by the second volume. Now guys, what you have to do, you have to write here W option and press enter, that whether this two volume has been created inside SDB or not. So for that guys, again repeat the same command fdisk/dev/sdb, and here guys, you will write P for knowing the informations. So guys, here you can see that we have SDB1 and SDB2, the two different volumes, and guys, here is the block size. Guys, we have created the two different volumes of 5 GB each. Okay, now guys, our work is that we want the one of the volume to be used by root volume, means root, we want that root volume would be extended by 5 GB, and so we will use the SDB1 in order to extend the root volume. So for extending the root volume with 5 GB, what you have to do, you have to transform one of the volume existing on SDB into PV. So guys, we will convert the SDB1 into PV. So for converting that, right here PV create slash dev slash SDB1. Okay, we know that guys the capacity of SDB1 is 5 GB. Press enter. So guys, we have successfully created a PV for SDB1. Moreover guys, if you want to verify this, then right here PV display. So guys, you can see that we have a new PV which is SDB1 having the capacity of 5 GB only. Okay, now guys, what we have to do, we have to add this PV into the same VG, or you can say the volume group of which root volume is also a member, or you can say the root drive or LV underscore root is a member of that same VG. So guys, in order to include this PV into the old existing VG, we have to use VG extend, and guys, name of the volume group which is existing means name of the default volume group which is already existing on Linux. So the name of my default volume group is VG underscore Vishnu, and guys, here you will write the name of the PV that you are going to add. So for that I will write SDB1 and press enter. So guys, you can see here the message that volume group VG underscore Vishnu had successfully been extended. Now guys, we will extend the root drive. Okay, so guys, before extending the root drive with this SDB1, or you can say before extending the root drive with 5 GB, first we will know that what is the current size of the root drive. So in order to know that, we will write LV display, and here guys, you can see that the current amount or the space of this LV underscore root, or you can say this is the name of the root drive, is 8.51 GB. Okay, so guys, after extending with SDB1, this size must change. So guys, for extending the size of this root volume, we will use the command of LV extend minus capital L plus 5G. So for this you will use 5G and the name of the root volume which is VG underscore Vishnu LV underscore root. And guys, so here guys, we are extending the root volume with 5 GB, as you have written here 5G. G means GB. And guys, press enter. So now guys, here a message has appeared in front of you that extending the logical volume to 13.51 GB. Now guys, if you write LV display, then you can see here that the size of your LV underscore root has increased from 8.5 GB to this 13.51 GB. Here you can see the LV underscore root. Okay. Moreover guys, if you want to see the same thing with the help of the graphical console, so guys, under administration you will click this logical volume management, and then guys, this wizard will appear in front of you. Okay. Now guys, here you are seeing the volume group, and the name of the volume group is VG underscore Vishnu. We know that guys, volume group is made up of PV and LV. So if you extend this VG underscore Vishnu, then you find the PV and LV. So now we will see that what are the PVs which are member of this VG underscore Vishnu. So before that, if you click on this VG underscore Vishnu, which is your VG, then here you can see that it is made up of this 2 LV, which is LV underscore root and LV underscore swap. Okay, and guys, it is made up of 2 PV, as you can see here, the SDB1 and SDA2. Okay, now guys, if you click on PV, Then here guys, inside PV you can see we have SDA and SDB, and guys in SDA we have only SDA2 acting as a PV, and guys you can see that this LV underscore root and this LV underscore swap, which are two LV, they are occupying the space of this SDA2 volume. Okay, in the same way guys, if you see here for SDB1, so guys this SDB1 is occupied by also LV underscore root, as we have extended that LV underscore root with SDB1. Okay, so from here also you can get the different informations. And then guys inside LV we have this 2LV, LV underscore root and LV underscore swap. One thing more guys, I want to say you that from this graphical console also you can create LV, you can delete LV, or you can create VG, you can delete, or you can extend or reduce the size of LV. But this is somewhat good for the client side of Red Hat Linux operating system, but as far as server is concerned, it is far good to do all such type of lab through the command prompt. Okay, so see guys, if you want to extend the size of root volume, or you can say LV underscore root, then here guys we are having the option like remove the logical volume. This is the first option. As you can see, if you click it, then this LV underscore root will get removed. So guys here message has appeared, and if you click yes, then your LV underscore root will get deleted. Also guys, here is the option of create snapshot. So if you want to create the backup or snapshot of this LV underscore root, so here is the option. So if you click create snapshot, then here is some order. And guys, if you want to extend or reduce the size of this LV, then here is the option of edit property. If you click it here, then guys here is the full form, you can say, where you can change the name of the root, you can size of this LV, you can change the file system of this LV. Learn that how to graphically manage the hard disk with the help of that LVM console. Now guys, the last lab is that we are going to mount SDB2 into a specific folder so that we can utilize the space of SDB2 in storing our different type of data. So for that guys, first we will create a folder inside root drive. I am creating the folder inside root with the name of data. Okay, so I am creating a data name folder. So guys, your data name folder has been created. Now guys, we already know that we have already created SDB2 named volume, which is of size 5 GB. So now what you will do, we will format the SDB2 named volume with the help of below given command, that is mkfs.ext3 minus capital L and the name of the folder on which we are going to mount this volume. And guys, here we will write the name of the volume which we are going to mount, which is SDB2. Okay, because we have used the SDB1 in extending the root volume, so we are using here the other volume, that is SDB2. One thing more guys, here I want to make you aware with is that this ext3, what is this ext3? So guys, in Windows environment we know that there is file system, and the file system which is used in Windows environment, it is NTFS, FAT32 and many other kind of things. But guys, in Linux environment guys, we are having the file system as ext1, ext2, ext3, and now the latest version of file system is ext4. So here guys, the file system is somewhat different. So with the help of this here in this lab, we are going to format this SDB2 with the help of file system, which is ext3. So just press enter. Formatted the SDB2 name volume. Now guys, we will mount it on the specific folder that we have created earlier with the help of SDB2/. data. So guys, actually this is the name of the volume that we are going to mount, and this is the name of the folder in which we are mounting this SDB2. So guys, what is the mainly meaning of this mount? So guys, we are mounting this SDB2 in data folder. So guys, what now will happen is that though this data name folder will appear on the root drive, but guys, whatever the data you save inside this data name folder, it will be saved or it will exist inside this SDB2 name means SDB2 name volume. Okay, so guys, this is the main thing of mounting, or you can say the main concept. So guys, we have successfully mounted this SDB2 name volume in this data name folder. So enter. So in this way guys, you will not understand that whether this SDB2 is mounted successfully into that folder or not. So for that you have to go inside the file system, and here guys we have created a folder named data. So here here is your data name folder, and guys at the present moment, if you are in the root drive, then here you can see that the free space is 2.9 GB, means the root drive is having only the free space of 2.9 GB on which all the folders are created. The symbol of root drive is this, but when you enter inside this data name folder, then here guys you can see that 4.5 GB is the free space. It means that your SDB2 is successfully mounted to this data name folder. Ultimately, I want to make you aware with one more thing, that okay, we have mounted this SDB2 to a folder named data. Okay, so whatever the data you will store, it will get stored on SDB2. But if you will restart your system, then this SDB2 will automatically get unmounted, and now the means whatever the data you keep on this data name folder or inside this data name folder, it will not get stored in SDB2, but it will get stored inside that SDA2, which is by default created PV. Okay, or you can say inside the root volume. So in order to avoid this dismount or unmount after the restart, you have to edit a specific file which is fstab. So what you will do, you will write here /etc fstab and you will press enter. Then guys you will come, or you first press escape and come into this insert mode. For press I, and then guys come at the below of this file, press enter, and guys here you will give the information related to your volume which you want to be mounted every time, irrespective of the reboot of the system. And here guys give the name of the folder in which you are going to mount, and guys here we will give the file system by which we have formatted the SDB2, and guys here we will write default 1 2, and guys here you will save this file. Okay, so now guys our lab is complete, and guys if you are facing any problem related to LVM, then you can ask me through the YouTube video channel. Moreover guys, I would be creating more videos on LVM and many other kind of things, so please don't forget to subscribe my video channel. So thank you.